start with the mobile application testing part. And over here on the screen, you can see this is a virtual mobile application, which is your Genymotion part. Genymotion is just like your virtualization for mobile application. You can see over here, you have to install Genymotion. And over here, you will see API, Android APIs. So you will see some versions like 4.4 to 10.0. So each and every application you can see, you can select anyone. So you can select any of the device, or you can select the type you want, the density, the size. It's all about there. And each and every device over here has a different kinds of architecture. 5.5 has a different one. You can simply install like this one. You can install any of the device. For example, they have given Google Nexus 10, 4, 5, 6, 7, 13, Samsung Galaxy S3. So you can use any of the API.
सर एक चीज बता सकते हैं आप?
Yes, बोलिए.
सर एक बार REST API का मतलब बता दीजिए क्या होता है?
Which one?
सर API लिखी है यहाँ पे, तो शायद REST API होंगी है.
Reset API.
Yes sir.
Reset APIs. There's a different thing.
अच्छा.
Yeah. So over here you can see the applications. API means applications type over there.
Okay sir.
So you अगर आप यहाँ पे देखो, there are around different kinds of virtualization part. It's all about the hard drive and the features. You can select any of the one. See, there are many. According to the version, you will get all the things.
Okay sir.
But for the presentation, we're gonna use the 4.4. Because when you're implementing, when you're testing a mobile application, I will say to lower, you should go to low ground, means is the starting point or the lower application versions. So that's why over here you can see that I have custom phone, which is my Genymotion over here, and you can install this one on your virtual box, and you can see when I open my virtual box, it will make a VMware. Look, custom phone is running over there. Customization phone. So let me show you one thing where you can grab all this thing. Let's write Genymotion. You can see personal emulator. You can download for personal. You can see over here. Yeah, I will say you can download with the virtual box like this one. With the virtual box. And without the virtual box, but you have to install this one. And one more thing, you have to register all the things. So I will say download this one. So I'm going to share you the link on your chat. So you can download this virtual box in your local server. And there's one more thing that you can do is you have to look all the things one by one. So we need a Kali Linux that we already have for interconnected. You can see Kali machine over here, 19.3. I'm using the old version. You can use the latest version if you want. There's no issue with that. And in this virtual machine, we're gonna penetrate the application called Diva, which stands for Damn Insecure Vulnerable App. This on this challenge, we have around 13 challenges, and we're gonna examine all the things one by one. And from my side, I'm gonna provide you some notes, which is your, like you can see, there are 22 slides, and we're gonna start with the very first thing about the mobile application testing part. So as you can see on the screen, what are you gonna learn over here? So mobile penetration testing modules. Okay. So example, you can see essential for pen tester, Android developers, and security analyst. So over here you can see that cover all real-life Android vulnerabilities, basic to advanced penetration testing in mobile security views, various vulnerable apps like Insecure Bank and Diva. So over here you can see what are the modules that we're going to cover. The modules that we're going to cover is Android architecture and permission, Android app components, setting up a testing labs, reverse application using JDAX, API tool, JEXTUJAR, etc. Various vulnerable applications like insecure login, leaking content provider, insecure data storage, your client-side injection attack, SQLi victories, and over here API hooking, malware analysis, DOS attack, and penetration testing Diva, which is your damn secure, insecure vulnerable app, and your browser. You can add one more thing over here, and that would be your mob SF, which is your API scanner. And over here, if you want to learn more things, you can visit some websites over here giving introduction to Android architecture for popular smartphone OS, open source, first choice for the developer, you can see. And you can see over here, they have given some websites that you can get all the Android source code. You will get all the things that you want from here, the source code of Android applications. So you can simply see interface and architecture. This is an important part. Understanding how the application works. That's the really important. And over here, they have given all the things that you need for architecture, for capabilities, for display, for settings, for testing part. All the things is given. For example, you can see application framework, binder IPC proxies. These are the things that you're going to learn in our upcoming sessions. This is all about the architecture, which we're going to discuss later on. And the most important part is you will see lots of platform testing part. These applications are basically for Android developers. You can see securing Android essentials, design capabilities over here. So if you need anything over here, you can simply get, because they're going to give you all the architecture that you need over here. Apps, Android frameworks, native libraries, Android runtimes, HL, IDL, and Linux design capabilities, devices. You can see over here. Sources, essential Android devices that you need. The framework, this is the important part. The application, the Android framework, the native libraries, the Android runtime, the HAL, the Linux kernel. All the things gonna discuss over here in our upcoming sessions. So over here, that's why they have given this website. You can simply go over here and check. For example, so if you go down, you will see what is an Android first of all, the basic question. So as we know, Android is just like a Linux-based operating system, which is primarily designed for touchscreen and multitasking product, which has a form of tablet also. And you can see Android is being a more powerful operating system and support large number of applications in smartphones. And these applications are more comfortable and advanced to the each and everything. For example, you can see what is an APK. APK is just the format which is used on your mobile application to install an app. Android application package, which stands for APK, is a file format used to distribute and install application for software and middleware on the Google Android operating systems. And you can see APK files are zip file formatted based on JAR files, Java file formats, with .apk extension for the following information to check. So if I talk about Android application, that's only support only one format, which is your APK extension, because application set should be installed over there. and this one stands for application package file. So if you go down, you will see an Android complete architecture, how the mobile application architecture looks like. So over here, they have given one by one, for example, applications, which is the very first thing, but it starts with the bottom side. It starts with the bottom and it will simply jump one by one to all the levels. For example, you can see in the bottom side, Linux kernel. In the Linux kernel, you can see some drivers over there. So they have some drivers like display drivers, some camera drivers, some flash memory drivers, some binder, some keypad. You can see all the drivers of the applications are installed on the kernel Linux. And if you go down, you can see Linux kernels. At the bottom of the layer is Linux 3.6 and approximately 115 patches, means upgrades. You can see. This provides a level of abstraction between the device and the hardware, and it contains all the essential hardware drivers, which may contain all the things one by one. So you can see all the drivers like camera, keypad, display, etc. All the kernel handles all the things that Linux is really good for. Networking is a vast array, you can say, loop that is given one by one. It contains all kernel Linux kernel contain all the hardwares of the related applications. For example, you will see in the bottom side is given. And after the Linux, they come with libraries, which contains Surface Manager, Media Framework, FreeType, SSL, your OpenGL, your libraries, your SQLite libraries. So what is libraries over here? On the top of the Linux, you can see there is a set of libraries including open source web browser, which is also known as lib SQLite database, which is also a repository of the storage and sharing of the application data. Libraries to play or record audio and videos. SSL libraries responsible for internet security, etc. Each and every libraries has a different role in the real life scenarios. They have given SQLite is for database. Browser is for WebKit. You can see over here they have given all the things one by one. And all the things are related to interconnected. If you talk about C, well known as library libs. SSL libraries responsible for internet security, etc. They have different kinds of modules over here. And after the libraries, it comes Android runtime, which contains some core libraries and Dalvik virtual machine. Dalvik is the only thing which is run on your mobile application to run the operating system. So if you come down, Android libraries contain some things which is important in real life scenarios. This category emphasizes the Java-based libraries that are specific to Android development part. For example, they have given the libraries in this category includes the application firmware libraries. In addition, for those facilitate user interface building, graphic drawing, database access, a proper interface that human can interact with. A summary of some key and Android libraries available to Android developers as well as follows. Some of the key management that we should know is your Android.app, content, database, OpenGL, and OS. If you talk about the Android app, provide access to the application model in the cornerstone for the Android applications. Accessing the application form in the model type. If we talk about the Android content type, facilitates content access, publishing and messaging between the application and the application container. Means communication with the each and every applications part. Database, Android database used to access data published by content provider and includes SQLite database management system. As they have given OpenGL, this is a Java interface which provides graphics for rendering part. When you simply access to any of the applications, it will show you the pop-up. Android OS provides application with access to standard operating system services like messages, system services, and inter-process communications. All the things are given here one by one, and these five are important for the Android libraries. And we can simply think about that. This is the logic things which will work in the back end for the human interaction.
सर एक बार OpenGL दोबारा बता दीजिए.
OpenGL is to simply provide you the graphical interface. When you simply click on the application, you can see the API front, the application view. For example, when you're simply opening the gallery button, you can see all the pictures provided over there, and that time it will consume the graphic memory on that device. Is it okay, Yash?
सर जैसे क्या बोलते हैं हम लोग जब फोन यूज करते हैं तो हमारे जो बेसिक स्क्रीन आती है वो सब भी इसके बेसिस पे दिखती है हमें.
Exactly. OpenGL.
और सर जो एप्लीकेशन हम डाउनलोड करते हैं उनके ग्राफिक्स तो अलग होते होंगे ना सर, मतलब जरूरी थोड़ी कि जावा पे बने वो.
Graphics, it's not about the graphic, it's all about the architecture. See,
नहीं तो मतलब सर अगर हम लोग कोई एप्लीकेशन डाउनलोड कर रहे हैं तो उसको रन करने के लिए उसका जो जैसे हम लोग जावा के लिए हम लोग यूज करते हैं वो नेटबीन्स यूज करते हैं, तो नेटबीन्स तो एक फ्रेमवर्क हो जाएगा ना उसके लिए जावा के लिए, जैसे
but
पाइथन के लिए जैंगो हो गया. तो
but most of the applications in Android are work on Java.
नहीं तो
Most of
अगर
the,
जो नहीं करेंगे फिर उनका कैसे होगा सर?
there is no reason that none of the work, because most of the application you can see that in this course you will learn about the Java. Each and every application is based on Java, so we have to read the source code.
ओके सर.
That will be XML and your Java program in Java.
ओके सर.
That's why you can see the Delvic machine. Delvic machine is where you can simply execute our operating system type.
ओके ओके सर.
Yeah, you can see, you can come over there. They have given more things like your Android text used to render, manipulate the text in a device display. Android view, the fundamental building blocks to application user interface. We get a rich collection of pre-built user interface components such as button, label, list view, your layout manager, your radio button, etc. Your WebKit is a class of intended to allow web browsing capabilities to build into the applications. These are the core things which is needed for the core application part. Text messages is basically used on your message protocol. View, you see the interface. Widget is all about your gadgets. Your labels, you can say the buttons. WebKit is all about the your web browsing part. And you can see, having covered the Java-based core libraries into the runtime, it is now time to run attention for C, C++ also. Most of the applications are based on these languages. You can see Android runtime, which is given. It was Android libraries. Now it's Android runtime. It's all about the virtualization. See this one, Delvic machine. For example, over here we use VMware for virtualization of the operating systems. But in the mobile cell phones, we use Delvic virtualization part. This is the third section of the architecture and available for second layer in the bottom. This section provides a key component which is called Delvic, which is a kind of Java virtual machine specially designed to optimize the Android architecture. And what is the use of Delvic? It's give you the features, core features like memory management and multi-threading, which is interact in the Java languages. Which enables it enables the Android application to run its own process. It has its own intention of Delvic virtualization. Our operating system, which is running over there, is a machine name is Delvic. The Android runtime also provides a set of core libraries. You can see over here for the developers to write applications and standards program language. Same like your application framework also, which is over here. Application framework where all the managers or the log analysis. You can see activity manager, window manager, content provider, view system, package manager, technology manager. These are all the things one by one is given over there. And we have applications also. But when we are clicking home button or contact button, but in the back end, these are the layer which is work. These are all the layers. If you see over here, Android runtime and Android app framework, and an application framework layer provides many higher level services to the application in the form of Java classes. Application developers are allowed to make use of these services in their applications. These are the common things that each and every application uses those things. Like activity control all suspect of the application lifecycle and activity stop. Means they are logs, you can say. Content provider allow application to publish and share data between other applications. Interact within the application in the same device. Content provider. Resource manager provide access to non-coded embedded resource such as string, colors, settings, and user interface layout. Notification manager, which allows to display alert and notification to the user. See, these are the common things. And the view system, an extensible set of view to use to create an application for user interface. I guess these are the things are in the real life scenarios. Yashashvi, remember one thing, when you're doing something, you have to think about that, how the device works.
Okay,
and
sir.
these are the common things, okay?
Okay.
In this course, it will be totally you will say it will totally your practical part. But you have to know about the component, how does it works.
Sure, sir.
For example, you can see the application. The last thing is the application part. You can find all the Android application to the top layer. You will write your own application to be installed on the layer. Such example they have given contact, books, and browser. But when you are simply when you're clicking on any of the applications, think about the backend. What could be the backend in there? And the most important part, when you're running an application, the kernel will execute the driver first. Then it will go to the libraries to check the connection. Is it a browser based? It is a database based, or it's a graphical based? You can see one by one all the things, and all it's a secure connection based. Core libraries you can see, and the Delvic virtualization machine. So over here you can see the application framework where we'll simply get the activity managers, the Windows manager, the content provider. These are the basic things you have to know. And we have the last and the least, we have applications to involve. There are many things that will become in your upcoming sessions, but these are the most common things. That's why so if you look over here on the Diva, on the mobile application, think about how the camera is working. What are the things over here? What is the setting over there? You can see there are lots of application, messaging applications. There are, you can see we get this was we were talking about. See, it's also connected with the core mechanism. So that's why in our sessions we're gonna cover lots of things. For example, let's see the second module, security architecture. Security architecture is an important part because we have to give the permission. For example, you can say security architecture, a central design point of Android security architecture is no application by default has permission to perform any operation that would adversely impact other applications or the operating systems or the user or the application process security. See this one. None of the application has the permission to simply access of other data, but you have to check all the permission one by one. Android has built-in security feature that significantly reduce the frequency and impact of application security issues. And this is basically depends on the file permissions. Your application with the default setting and file permission and avoid difficulties decision securities part. And they have given all the things one by one. If you are simply installing an application on your server or your mobile device, I will say mobile device, sorry, you have to check what are the permission they are taking to access that specific file. You can see the following core security features help to build a secure application. The Android application sandbox, which isolate your app data and code execution for the other apps. An application framework with a robust implementation of common security functionality, such like your cryptography, permission, and security of IPC. Technology like your ASLR or NX, Profix, these are the things are basically used for your security associate or your memory layout. An encrypted file system that can be enabled to protect data for lost stolen part. They have given one by one all the things. User granted permission. It's all about whatever the applications you are installing on the server, you should have to give a proper permission to over there. For example, which kind of permission? They can take the storage data permission also. They can take internal permission. They can take an external your permissions or the content provider. See, what kind of data can we look? They have given one by one all the things. By default files, you can create an internal storage and accessible on your application. Android implements this protection and it's sufficient most applications. Generally avoid to the mode world readable files. You can see one by one all the things is given. Use external storage. File created on external storage such as SD card are globally readable and writable. Because external storage can be removed by the users and also modified by the application. Content provider offer a structured storage mechanism that can be limited to your own application and secluded to the access to the applications. If you are not intended to provide other applications with the access to your content provider, you can simply block that and make them as Android exported false in the application manifest. See this one. The manifest is the most important file on your upcoming session. It contains all the permissions to be granted. Let me show you. Okay, I think in this chapter there would be. See the permissions, the permission control, and the Linux privilege control allocate separate and PID. PID stands for process identification. Each and every application has a process over there. And if you go down, you will see permission control, mobile permission control. Organization can disable the entire range of application permission access by the Android and iOS app to protect your end user privacy and guard against the use of compromised applications. Mobile permission control is available as a part of Mobile Security Institute and AppDom. So some of the applications are basically used for feature to prevent the application functions or the code you can see. Because in the last thing, you have to learn the source code, what are the code are running in the backend process. Privilege control, you can see over here. Privilege control, which is your PAM, privilege access management, refers to a class of solution that helps you to secure, control, and manage the monitor of each critical access. It's log analysis one. So you can see they have given all the things one by one. Allocate separate. PID, process identification. Each and every application, a process is the instance of a program running in the Linux. This is basic definition that you might have heard before the law. They have given some text part. See this one. Process identifier, PID. Each and application has a unique identification associated with a known process ID. This ID remains unique. For example, you can see this is a Linux architecture. Every application is given separate UID, user ID, and the PID, process ID number. User application is the owner of the PID. User means who's the creator of that application, and PID is the process ID number. You can see one by one over here. See, for example, if you go, the important part that we were talking about is called your Android manifest.xml file. This is the important file for the application to get a permission to install on that environment. Every application must have an Android manifest.xml. In the root directory, the main present essential information about the application to an Android system. Information the system must have before it can run over the application code is one of the most important file in the Android package C. It specifies the properties and Android applications. All the permission is declared by the developer. Can't be added later on. See, when you are simply installing an application, Android manifest contains all the permissions that it will gonna take. See this one. This is an XML file, and you can see user permissions just like this one. User permissions like your internet, your camera, your hardware camera, your external storage, your external storage, your wake lock. So why we should give this all the things one by one? Because Android manifest contains all the permissions on the mobile application file.
It's a file or what?
It's a file. It's a file. I'm gonna show you this. I'm gonna show you this one.
Okay, sir.
It's a file on your each and every application has this one. Some of the application need some permission to execute the function to call in an application. So it's necessary to all the right to privilege is given to the some of the applications on the Android development part. See, this is the application part which we're gonna see. Let me show you one example of this one. Let's open the Kali Linux. So as I mentioned you that we need Genymotion first of all, and over here we need we need Genymotion, and we need an application to be run. And over here, as per our first class, let me show you. We need JEDEX also for reverse engineering part. So JEDEX is all about to read the source code. It helps us developers to read the source code of an application part. So over here, let me show you. So I already have installed JEDEX. Let me show you one thing. Yeah, over here. JEDEX. So in the JEDEX, you can see you have to go to the bin directory, and in the bin directory you can see JEDEX.gui file and JEDEX.bat. So let me show you one thing. So when you're opening the JEDEX, you have to put an APK file over there. So you can see the diva.apk file, and over here you can see all the source code. The source code over here, which the username is jaka.asim diva. He is a creator, and over here you can see all the source code which has an application file. And the most important part is your Android manifest file. See this one. This one we were talking about. Like jaka.asim.diva has like permission. Each and every application has an android.manifest file which contains all the permissions like this one. And this is assigned by the developers when they simply implement. So over here, Android manifest.xml, you can say JDAG is to read the source code of any of the applications. And over here, we're gonna understand how the source code looks like over here, one by one. Is it okay, Yash?
What, sir?
We're gonna see the source code over here, one by one.
Yeah, sir, sure.
Yeah, okay. So,
Do you have a batch at one, sir?
I guess I have.
Okay.
So over here they have given the compilation file, how the file works. So it's all about the Android development, Android application development cycle. So this module we're gonna continue this one on tomorrow. Okay.
Sure, sir.